Right now, somewhere out there in the vastness of space, life could already exist, not as a distant possibility, not as science fiction, but as something real, evolving on a world we haven't reached yet. And what makes this moment in history different from any other is that we are no longer just wondering. We are gathering evidence. Piece by piece, discovery by discovery, science is starting to point in one direction. Before we go deeper, if you're genuinely interested in space, the science behind alien life, and understanding how close we might actually be to finding it, take a moment to like the video, subscribe, and share your thoughts below. These topics don't just answer questions. They open entirely new ways of thinking about our place in the universe. And the more you engage with them, the more everything starts to connect. For most of human history, we believed Earth was unique, the only place where life could exist. That belief wasn't based on evidence. It was based on limitation. We simply didn't have the tools to see beyond our own solar system. Now we do. And what we're finding is forcing scientists to rethink one of the most fundamental assumptions we've ever made. It begins with exoplanets, planets orbiting stars beyond our sun. Not long ago, we didn't even know if they existed. Now we've confirmed thousands, and scientists estimate there could be billions of them in our galaxy alone. But the real shift isn't just in the number, it's in the type of planets we're discovering. Many of these worlds are rocky, similar in size to Earth, and located in what's known as the habitable zone. This is the region around a star where temperatures allow liquid water to exist, not frozen solid, not evaporated away, but stable. And water, as far as we understand, is one of the key ingredients for life. Planets like Proxima Centauri b, orbiting the closest star to our solar system, exist within this zone. Others, like those in the TRAPPIST-1 system, show that multiple Earth-sized planets can exist around a single star, some of them potentially habitable. When you start to scale this up across hundreds of billions of stars, the numbers become almost impossible to ignore. At that point, the idea that life only exists on Earth starts to feel less like a conclusion, and more like an assumption waiting to be challenged. But finding planets is only the first step. The real breakthrough comes from what we can detect in their atmospheres. This is where modern astronomy becomes incredibly powerful. Using instruments like the James Webb Space Telescope, scientists can analyze the light that passes through a planet's atmosphere. That light carries information. Chemical fingerprints that reveal what gases are present. And this is where things begin to shift from possibility to probability. Certain gases, when found together, are extremely difficult to maintain without biological activity. Oxygen and methane are one example. On Earth, these gases exist together because living organisms constantly produce them. Without life, they would react and disappear over time. So, when scientists detect similar combinations on distant planets, it raises a powerful question. Could something be producing them? One of the most discussed examples is K2-18b, a planet where observations suggest the presence of gases that could be linked to biological processes. The data is still being studied, and scientists remain cautious, but the implications are significant. We are no longer just identifying planets. We are starting to analyze them in ways that could reveal signs of life. But alien life might not be something we need to travel across the galaxy to find. Some of the strongest candidates are much closer, hidden within our own solar system. Europa, one of Jupiter's moons, is covered in a thick shell of ice. Beneath that ice lies a vast ocean. Not a small one, but a global ocean that could contain more water than all of Earth's oceans combined. What makes Europa so compelling is the possibility of hydrothermal vents on the ocean floor. On Earth, these vents support entire ecosystems without any sunlight. Life there relies on chemical energy, not photosynthesis. If similar conditions exist on Europa, then life could exist there as well. Not complex organisms, but microbial life, thriving in darkness, completely independent of the sun. Enceladus, a moon of Saturn, provides even more direct evidence. It actively ejects plumes of water vapor into space. These plumes have been sampled by spacecraft, revealing organic molecules, the building blocks of life. More importantly, scientists have detected signs of heat and chemical reactions beneath the surface. This combination of water, heat, and chemistry is exactly what we associate with habitable environments. Then there's Mars, a planet that today appears cold, dry, and lifeless. But billions of years ago, Mars was very different. It had rivers, lakes, and possibly even oceans. The atmosphere was thicker. The climate was warmer. Conditions that could have supported life. Recent missions have discovered organic compounds in Martian rocks. They've identified patterns and structures that resemble those formed by microbial life on Earth. While nothing has been confirmed as biological, the evidence suggests that Mars may once have been capable of supporting life. If life did exist on Mars, even in its simplest form, it would mean that life can emerge more than once within the same solar system. That it is not a singular event, but something that can happen wherever the conditions are right. And then there are even more unusual environments being considered. Titan, Saturn's largest moon, has rivers and lakes made not of water, but of liquid methane. It's a completely different type of environment, yet scientists are exploring whether life could exist there using entirely different chemistry. Life that doesn't rely on water. Life that operates on principles we don't yet fully understand. This expands the definition of life itself. It suggests that we may have been looking too narrowly, assuming that life must resemble what we see on Earth. But beyond planets and moons, there is another layer to this story. Observations that don't yet have clear explanations. In recent years, there has been increasing attention on unidentified aerial phenomena. Objects observed moving in ways that don't match known aircraft or natural behavior. These observations have been recorded by trained military personnel and captured using advanced sensor systems. Organizations like NASA have acknowledged that some of these objects remain unexplained. This does not mean they are alien spacecraft, but it does highlight an important point. There are still things we don't fully understand, and in science, unexplained observations are not ignored. They are investigated. What makes this relevant is not the idea of aliens visiting Earth, but the recognition that our understanding of the universe is still incomplete. Just as we once believed other planets didn't exist, there may be phenomena today that we simply don't yet have the framework to explain. And when you combine this with everything else, the number of habitable planets, the detection of possible biosignatures, the existence of ocean worlds, the evidence of ancient environments on Mars, and the potential for life in extreme conditions, a larger picture begins to form. A picture where life is not rare but expected. This leads into one of the most profound questions ever asked. The Fermi paradox. If the universe is filled with so many opportunities for life, where is everyone? There are many possible answers. Intelligent life might be rare. Civilizations might not last long enough to spread across the stars. They might exist, but be too far away for us to detect. Or they might be so different from us that we don't recognize them as life at all. Another possibility is that we are simply early. The universe is incredibly old, but complex life takes time to develop. We may be among the first civilizations to reach this level of awareness. Or perhaps the answer is even more complex. Life could be widespread, but hidden. Existing beneath ice, beneath oceans, in environments we can't easily access. Not broadcasting signals, not traveling across space, but simply existing. What makes this moment in history so important is that we are actively searching. Missions are being planned to explore Europa and Enceladus more closely. New telescopes are being developed to detect even more precise atmospheric signatures. Artificial intelligence is being used to analyze massive datasets from space observations, searching for patterns that could indicate life. Every new discovery adds another piece to the puzzle. Not definitive proof, but direction. A growing sense that we are getting closer. When you step back and look at everything together, the discovery of habitable exoplanets, the detection of possible biosignatures, the existence of ocean worlds, the evidence of past environments on Mars, and the sheer scale of the universe, it becomes increasingly difficult to maintain the idea that life only exists here. None of these theories alone proves that alien life exists, but together, they point in the same direction, toward a universe where life is not an exception, but a natural outcome of the right conditions. And if that's true, then the real question isn't whether alien life exists, it's how close we are to finding it. Because when that moment comes, when we finally confirm that life exists beyond Earth, it won't just be another scientific breakthrough. It will change everything. Our understanding of life, our place in the universe, and the realization that we may have been part of something much bigger all along. Because if life exists out there, then somewhere right now, we are not alone.